So this arrived in the mail today. It got here much quicker than I expected. I think it was due next week, and then I had an update it was going to get here Saturday. It is Friday, and this showed up a little while ago. Postman dropped it off at my door because it was signature required. It's a lot heavier than I expected. I know what's in here, but there may be stuff I didn't realize was coming as part of the delivery. I just don't know. They have used paper grocery bags here. Knocking batteries over. Knocking instructions over. So I was saying, they've used brown paper grocery bags here on the outside. Don't want to tear up. Oh my God. Happy I tore that away and didn't cut any deeper. Journal of the Bigboard users. Well, there's a good hint as to what this is. You may or may not recognize that. Obviously, the box is for something else. We'll go ahead and take a peek at what's inside. Very cool. For those who don't recognize it, it's a Ferguson Bigboard. Not the Bigboard 2, but the original Ferguson Bigboard. And it just fits in there. Saying it just fits is a little... It's really tight in there. That box was just pretty much exactly the right size. I appreciate the use of anesthetic foam. Let's go ahead and move this out of the way. So it's a Ferguson Bigboard. The Bigboard 2 was a later generation design. This was the original Bigboard. It is a Z80 processor. These are, of course, power coming in over here on the side. I'm going to instantly release those. Remove the wires. They're just irritating. Not using the right screwdriver for this, but it's good enough. Sorry, should be talking here and I'm not. Come on, get down in the slot. There's some shredded bits of wire there. So it's a Ferguson Bigboard. There's a Z80 processor here someplace. Let's actually flip this around so I have a better shot at reading what's on stuff. It really needs to be cleaned up. We will certainly do that. So there's the Z80A CPU. I believe it actually runs at 4 megahertz. On the design, 2716 EEPROM. This has got PFM version 3.3 in it. PFM is the monitor. There's a Z80 processor. There's an FD1771 that controls a 8-inch single density floppy drives. You know, up to 2 drives, I believe, can be controlled. If I remember what I've read, but you know, the FD1771, you know, an original. Well, it's single density for the 8-inch. It would, you know, let's don't dive into that. But 8-inch floppy controller. There's a couple of configuration jumpers on here that I'm just going to slide off. I don't remember what the jack numbers are. There is video generation. So let me find the video generation circuitry. There's the 2114s for the video RAM, the character generator in a 2716 again. You can kind of read it in AMD 2716. So there's video generation here, 24 line by 80 column video. One of these connectors is for a parallel ASCII keyboard. There's potential of serial ports. This board looks very stuffed out, so it's got all the serial ports on it. I really can't read down through. While we're here, I'd like to know what some of these parts are, so I'm going to pour up a little alcohol, get a few Q-tips, and we'll knock some of the grunge off. This is certainly set someplace where it got very dusty, but that's no surprise. I know it belonged to, I believe she said it was her father's. So that's a Zilog SIO serial IO. No surprise. That looks like a PIO. So there's a serial IO chip, a parallel IO chip. Again, from the Zilog family. This is most likely a CTC counter timer clock. And it is. So there's the CTC. We've already pointed out down here the Zilog processor. I'm guessing, I don't honestly know, probably part of the video. I wish I could read the part number off of there. Mustech MK3881 ZD PIO. That's the second PIO. So there's two PIOs there. We already know this is the Western Digital 1771 floppy drive controller. You know, look at this. It's excellent. All of the major chips here, these 28 and 40 pin packages are in machine tooled gold sockets, very similar to these sockets right here. I'm sure they're the same brand of sockets as these here. There's an exception to that, which is this the character generator here, that 2716. Lots of just very common logic. I know these are banks of 4116s, they're -3s, all of them. So they're all 300 nanosecond. I'm just looking to see if they're all matched sets. I didn't want to stick that dirty end. Oh, I didn't want to stick that dirty end in there either. Yeah, it looks like they're all matched sets, which is really nice. There's a different one there, so there has been a replacement at some point, or yeah, there's a couple that appear to have been replaced. That's no surprise. 4116s do go bad. As I said before, these are 2114-3s, 300 nanosecond. Guessing a big chunk up here is video. It's got composite video out, and then it's got video horizontal and vertical sync as separate outputs. Like I said, it's 24 row by 80 columns, so it requires a high bandwidth monitor. The idea in reading about this is this was meant to be a complete standalone computer. It'll run CPM. The full CPM library is available to it. If you weren't looking for large amounts of expansion, but just a system that had serial I/O, parallel I/O, video generation on board, keyboard, etc., it's a complete solution on a single board. And you may not have noticed, but the size of this board is the same size as an 8-inch floppy drive. It can mount, I guess, on the bottom of a floppy drive where the screw holes are, but it's the same size as an 8-inch floppy. Meaning a single 8-inch drive in this in a case becomes a complete system, which is really pretty cool. There's the Ferguson logo. The Ferguson. I'm assuming that's the gentleman's name. You know, it really looks to be in really good shape. It just has been stored where dust was able to get to it. So there's two 1488s and two 1489s here. And it's interesting that they have disc caps on them. At this age, they usually need 1 microfarad caps going this far back. Maybe those are on 1 microfarad discs, I don't know. But there's the serial converters. So the the TTL level to RS-232 level shifters for the serial I/O. So just continuing to see lots of glue logic. As far as I know, there's no PALs. I'm not seeing anything like a PAL or a GAL. It's all done in discrete logic, and it really does look to be all discrete logic. Everything I'm seeing here is ZLS logic. Here's a date code of 22nd week of 80, 16th week of 82, 18th week of 82, 24th week of 80. The DRAMs are from 79. Looks like all of them are late 79. 49th week. Well, these may actually be somewhat matched sets. 49th week. It's interesting that the markings differ slightly. That's 51st week of 79. So there's a couple that are different. There are some piggyback chips here. There's 2 of them that are piggyback. That's interesting. 274 157s, and they are a pure piggyback. Why would you piggyback all pins? Well, we're going to pop one of those out and take a look. Chip lifter. All those pins are soldered, and all those pins are soldered. Why? Did they need like double the drive? Did they need more fan out? Is that what's going on here? Why? I mean, you see this sometimes in DRAMs where somebody will fully piggyback one DRAM on top of another, but that's not on boards where there's no sockets. Because sometimes DRAMs will fail in an open mode. Look, the sockets are all gold pins. There is some corrosion there. Are all these sockets gold pins? That would be amazing if it had that kind of build quality to it. But all 16 pins are soldered directly down. The only reason I could think of to do that in a socket would be trying to get better fan out. Fan out being how many TTL inputs you can drive off a single TTL output. Ultimately, it's all how hard you can pull down or pull up an additional pin, and that has to do really with just how much current you can source or sink. So I have no other explanation for that. I've never seen that before, at least not in memory. Bring him back up straight without snapping him off. Wire up tools are really good for what you just saw me do, for kind of getting on these pins and straightening them back out. It's a pretty good tool to do that with. It's actually designed to fit over, a pin of that same size. Fits down between 0.1 inch rows. It's actually a pretty good tool for that. It's not perfect. This one is really messed up. But I'll come back to it. I thought I'd apply power to this today, but I don't think I will. I'll go ahead and pull one of these out if I can find the chip puller. Here it is. So I'm going to attempt first to get the CTC out here. Oh, missed on one side. Because what I want to show you here is how bad the corrosion on the pins are. So those are pretty bad. They're not as bad down in where they were in the socket, but those are really pretty bad. And that's a larger socket cut down to 28 pin. It looks like this PIO here has the same kind of pin rot to it. Luckily, these are coming out very easily. Those are even worse. Not unexpected in something of this age. Yeah, this PIO's got the same problem with the really dirty pins. I've still not found a great way to clean those up. The best, I hate to say it, the best I've come up with is fiberglass. The fiber bristle brush seems to work the best. I've got brass and steel here I'll try as well. And I ended up buying a smaller fiberglass tool here. It's actually pretty well made for what it is. I say that and the fiberglass won't come out. This was spendy, but I also got a bunch of fiberglass refills for it. The problem with working with this is it breaks off little bits of fiberglass as you clean the pin, and you end up with fiberglass dust that gets into your skin and makes you itch, and you don't want to inhale it. And so, but for pin cleaning, that's kind of the only method I found that seems to consistently work. I really feel like I need to strip all the ICs out, give the board an absolutely thorough cleaning and deep inspection, because I seriously doubt it'll come up and run in the state it's in. Soldering job doesn't look too bad. Really doesn't look too bad to me, the soldering job. Silk screen is still nice and intact. There's a little bit of rework on the back. There's a jumper right there. So there was a little bit of engineering change or something at some point. There's been some trace damage here that looks like it's been just repaired with solder, because there is actually solder on that copper. Yeah, the silk screen is really aged there. So excessive heat or something. I don't think the copper was broken. I keep trying to remember to order some clear fingernail polish, which you can use to cover this kind of stuff up. But with the solder on there, the copper, the solder mask is on top of the copper to keep the copper from oxidizing. It's pretty much exactly what I would have expected. I've been looking for a Bigboard for years. There's some Bigboard 2s up on eBay. In South America, they're asking $800 to $1,000 for, that have been there forever. They've been there for years, and I've ignored them, honestly, because no, I'm not going to spend that kind of money. There's other stuff that I prefer to have than spending that much money for a single board computer. I saw this one originally listed, and I want to say there was a buy it now of $800. I don't remember this. This got listed a few times. It was listed. I looked at it and thought, no, there was an original bidding price that was, I don't remember the numbers now, but it was more than I wanted to spend, and so I just did my best to ignore it. I did watch list it. It ended. I checked a couple days later. It was back up again, and the cost had come down, but it was still more than I was willing to spend. And then it ended and popped up again, and there was a buy it now at a price that I felt like I could afford. It was reasonable. It was spendy, but it was reasonable. And I went ahead and spent it. I don't really need another CPM computer. Although, honestly, this could make for a really compact. I've got my Altair 8800 and the dual 8-inch floppy, stuff you've seen in previous videos. It's just big and difficult to work on. I've got an RC 2014 that's a nice little CPM platform, but it's got no floppies. The size of this might actually be a good kind of in-between, where, of course, powering an 8-inch floppy drive, their power hogs, is interesting. You know, I've actually got a case that would work well with this. I've got a case with a half-height 8-inch floppy drive and a metal case that this might be a natural for. I'll have to look at it, but that's down the road. Well, I'm waffling on and on here. Let's go ahead and see if we can. I'm glad these are coming out of the sockets as easy as they are. And that just attests to the quality of the gold socket. So come on, release. There you are. Yeah, those PIOs are pretty sad. I've been able to find manuals a couple different places. The scan quality is okay. And what I found for the the original Bigboard here, the schematics, I was able to print them on 11 by 17 and get a decent size with them. Yeah, the ZD pins look fine. They're readable. Whoever did the scans did a pretty good job. It seems to be the same set of scans on both bit savers. I found the manuals a couple different places. Dave Dunfield on his site has floppy images. I grabbed those, and there was some floppy images on bit savers as well, so I grabbed those. If I remember right, this is potentially a Moss IC and super static sensitive. I don't remember for sure, so I will have to get some anti-static foam in place. That piece has already got stuff on it for use before I actually pull him out, and then I'm going to want to get photos of this and try to get the parts out. And I kind of identified where they go, and I'll probably do that by basically putting them into foam in similar locations. What caught my eye here was the markings on this EG74LS293 are upside down compared to the rest of the chips. So that's an ECG replacement part, most likely, but it's just a 74LS293, so nothing exotic or weird. Yeah, I'm debating how to clean this. This is grubby enough, but it's almost... I hate throwing boards like this in the dishwasher. Sometimes that's just the best way. It's just the best way to clean it. You just got to be absolutely sure you've dried it well. I'm seeing a lot of pin rot in here. This device, the pins are all black. All black, all black. Several are black. Couple there. Again, no surprise at the age of these. There's a lot of corrosion or blackness on the pins. The DRAMs. Not as bad as that Apple II that we brought back to life many videos ago. But still pretty bad. So I remember this is a pretty standard machine, and then it's got I think the 8K of ROM starts down at the bottom. 8K. I mean, it has to reset into ROM, and then there's some bits you can set that swap this out and drop the DRAM in its place, I believe. You got to be able to do that because CPM wants RAM at the bottom of memory. And there's all kinds of ways that's been dealt with over the years. There are S100 cards that inject no-ops onto the bus. So starting at address 0 on a reset, and just inject no-ops till it gets up to the first address of the ROM, and then the no-ops stop and it actually reads the ROM. And they use that to boot. And I've always thought that was such a weird design. Why wouldn't you just bank switch? But, the designer chose that. There are dumps of these two ROMs. I've already found them, but I'll be able to verify those against those dumps. I will probably burn a fresh set as well. there's a 20 megahertz crystal over here, so that's interesting to get down to 4. Divide by 5. Well, they may actually be dividing by 5. Unless they're going, oh, I don't know. I'm going to have to go back and look. I think it's a 4 megahertz machine. Maybe it's only a 2. This is 5.068 megahertz can here. I just want to look at the pins on it. I swear I didn't bend those that bad myself. I really swear I didn't. Especially this one that there was no way it was in the socket. Yeah, these pins are really soft and easy to bend. 5.0688 megahertz. I'm not sure. That's got to be clock timing for the floppy controller, would be my guess. I do like that every socket I've pulled a part out of. You know, these are double wipe. I've talked about this before in sockets. They're gold plated, which is just excellent. That's beautiful. But they're double swipe, and that means it makes contact both on the inside of the pins and on the outside of the pins. So the pin is pinched between a U-shaped piece of metal here with gold plating on it. And the idea to get a good connection that'll last is you need to keep the air from getting into the contact. You know, wire wrap works as a process really well, because when you wire wrap onto a pin, the sharp edges, you know, the 4 edges of the pin, the 4 corners are sharp, and they actually cut a little bit into the wire wrap wire, and that creates a gas-tight connection there that won't corrode. And so you can have wire wrap connections be 40 years old and be absolutely fine, because as long as you keep oxygen out of where it makes contact, it won't corrode. So, you know, you can see that most of the pins here, you probably can't see, most of the pins here are kind of cleanish, where they were in the socket, but the corrosion's actually walked down deeper into the socket. And part of that is because I had a pretty good connection into the pins here that was, again, creating a gas-tight connection. That's got to be crystal for the video timing up here. I'm not going to pull much more out just because I want to know where stuff goes, but this has got me a good look down into a few sockets. I guess I might as well pop out a DRAM while we're here. Pick somebody kind of easy to get to. I just broke that disc cap. Exactly opposite what I was trying to do. Doggone it. Yeah, pin corrosion really bad. Shoot. I mean, these are really brittle. You know, this cap here is broke. I'm going to have to probably inspect this for broken caps and pull these ones out. I don't want to generate a short on the plus 5 volt power rails because of a broken cap. So there's 2 of them here that are suspect at this point. One I just chipped, one that I think was already broke. Oh, excuse me. I just had ramen for lunch. So definitely a different type of socket here from the rest, which is interesting. Why that's a more generic socket, I don't know. Guess I can pop out one of the 2114s maybe. He's in there really tight. Pins look decent. Socket looks good down inside. I've probably got a 24-pin machine tooled, or machine pin 24-pin socket. I could swap one into there just for more consistency, although I don't think the ones I've got are gold plated. You know, I've read a couple things that have said this is, you know, it was a decent design. The physical design and implementation was well done. The socket's kind of a test to that. Well, I don't know if there's much else to say to this at this point. We've got a peek at things. We've kind of dated it, 79 on the DRAMs, kind of 80s on 1980 on most of the other stuff, although there's like an 83 and an 83. I'd be surprised if these were still being sold in 83, but maybe they were. I don't know the lifetime. I mean, by 83, 5¼ inch floppy drives were common. The TRS-80 line was established. Commodore, Atari, all those systems were established by then and being sold. So, you know, maybe they still appeal to people wanting to run the CP/M library. Hopefully I've been on camera here this whole time. Kind of give you a view. I'll try to rock it around. I think there's a lot of glare because it's so dirty. There's another bit of rework there. Looks like there's a little bit of wrap wire, a little wrap wire strap across 2 pins there. There's, of course, the wrap wire there. So those are the kind of things I want to visually find and get photographs of, so they can be re-implemented if need be. I don't think that jumper's between those 2 pins. It doesn't. Soldering job does not look bad at all. It just looks like it was soldered. If it was soldered in 1980, that would be 41-ish years ago. So you do expect some tarnish. Anyhow, I guess at this point we wrap this up, and I'll see you in a future video as we work on this thing to bring him back to life.